This is the 41st episode of the Rule Your Pool podcast. I'm your host, Eric Knight with Orenda, coming to you from my closet studio, and it's abundant silence around me. It's marvelous. A lot of people call us with their problems at Orenda. It's actually, the majority of the calls that we get are about problems, which we like. You know, it's people call us for help. It's part of the job. Most of what we do is we get out there and we educate on common things, and there's a lot of problems. I would say the most common would be plaster related. We're a chemical company. We're not a plaster company, but we get so many calls about, oh, I got this discoloration on my plaster surface, or I've got this spot, or I've got these lines, or I've got this, insert issue here. And they're hoping that we've seen it before, and usually we have. And today, actually, let me back up. I think the reason we get so many calls like that is because we're very loud and vocal about what water chemistry can and cannot do. And I think in this industry, so many people have been taught for so long that water chemistry is usually the cause of any of these issues, or the majority of them. And in some cases, that's true, or at least is not completely untrue, I should say. But it's not always the case. And depending on what it is, water chemistry may have nothing to do with your problem. And it's not a topic that we really like talking about, because who wants to find out that the issue they have is actually more severe than they thought? It's never a fun conversation to have. But nevertheless, today we are going to talk about concrete pool shell issues. They are more rare than simple plaster issues, but nevertheless they are common. And they have nothing to do with water chemistry. That's the thing. I would tell you if they did, because we would want to know a way to prevent these issues. But these are really hydraulic problems. These are structural problems that we're going to talk about today in our 41st episode of Rule Your Pool. So if you do have an in-ground concrete pool, this episode is for you. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. There are so many directions that this episode could go, and I'm going to do my best to stay cogent and stay focused on what we really need to talk about here. And the reason we're doing this episode at Orenda, because we're not a concrete company, we're not a pool builder, is because a lot of these issues are mistaken for water chemistry problems. Hey, water chemistry caused this issue, so therefore I need to understand the chemistry that caused it so I can fix it and prevent it. Not so much. Not today. These are actual structural issues, and there might be some disagreement on exactly what leads to what, and that's okay, because there's differing point of views on a lot of these things. We are not the concrete experts, and I'm not pretending to be. We understand plaster really well, because the sheer volume of calls and emails we get about it is enough to justify extensive research on it. For this topic, I talked to a bunch of experts. They know far more than we do, and I am not a concrete expert, and I've never built a pool. So I'm not going to pretend like I can replace the judgment of a good qualified pool builder in your area. Everybody's soil is different. Your local pool builder is probably going to know more, or at least they should know more about your local conditions more than I do. So keep that in mind. I just want to talk about three main problems that we see as it pertains to concrete shell issues. Those three problems are weepers, efflorescence, and calcium nodules. We're going to start with weepers because it's pretty much the simplest. All a weeper is a leak where water is pushing through the concrete and flowing. It is an active leak. So it comes through a crack or a void space or a weakness in the concrete. And I guess it would probably make sense to explain how a concrete shell is installed if we're going to understand weepers. Once the hole is dug, the rebar's in, the plumbing's in, all this other stuff, concrete is applied pneumatically. It's called shotcrete. There's two different types, and it has to do with where water is added to the concrete mix. One of them's at the nozzle. I believe that one's called gunite. So it's the hose is pushing dry mix, and then water is added at the nozzle under high pressure. That's called gunite. And you could also have wet mix concrete, which is pushed through the hose entirely, and that's also pushed under pressure, called shotcrete. Technically, they're both shotcrete because it's pneumatically applied concrete. What's important here is how that shotcrete is applied. So the main thing is it has to be under a certain amount of pressure, and it has to be a certain density. I don't want to overcomplicate it, but according to the standards from Genesis and Water Shapes University and other sources, minimum 4,000 psi, pounds per square inch, 4,000 minimum. Now, sidewalks and other concrete applications, they're probably not that dense. They might be. I don't exactly know because, again, I'm not a concrete guy. But I do know that 4,000 is the minimum density for a pool shell. And if you're going to have raised elements like a Vanishing Edge wall or a raised spa, they would recommend you even go higher, maybe 5,000. It just depends on who you ask. It depends on where you live. I don't really have an opinion on that, but don't go below 4,000. However, we see pool shells quite often that are failing, and upon further examination by other experts, not Orenda, they did not have proper density. I guess people drill out core samples and find out, wow, this is not 4,000 psi, it's a lot less. No wonder you're having an issue. So, shotcrete is applied pneumatically. It's actually cool. If you go on YouTube, you can watch. It's this big giant hose, and it just blasts concrete all around, and it's a pretty cool process to watch. Unless you do it, in which case it's probably obnoxious because it's your career. But it's very loud, and it's a very powerful process. Now, when that happens, when the hose shoots concrete at a high speed against a wall or a floor or whatever, inevitably some components of that concrete bounce out. They don't stick. This bounce out, or this excess shotcrete that doesn't adhere and doesn't stay in the matrix, is called rebound, because it rebounds out. These are like little chunks of gravel and sand and whatever else. And that stuff is often mistakenly collected by the applicators and troweled back into the wall or onto the steps. Usually it's like to complete the shape of a step. That's a mistake. That's not, according to all the experts we talked about, that's actually a really big problem. Rebound needs to be discarded, and it needs to be pulled out of the pool at the end of it. There should be quite a bit of it. It seems like it's waste, but don't quote me on this, but I think somebody was saying like it's okay because you can mix it into new concrete down the road. So it's not like you're throwing it away, but you're not including it in that day's job, because the concrete that was around this pebble or piece of gravel, let's say, it bounced off. So it's not going to adhere, and now you've got void spaces around it. It's going to be a weakness in the shotcrete. So keep that in mind. The shotcrete has to be very dense because no concrete is waterproof. Concrete is not waterproof. It's porous. It actually absorbs a lot of water. But the denser it is, it can be more watertight. Okay? Now, back to weepers. If you did trowel in a bunch of rebound, or it wasn't at the right density, or maybe the ground shifted after you left or something, and there's a weakness in the shotcrete shell, or it didn't cure properly, or whatever, water will find the path of least resistance. So if you have a high water table, groundwater pressure will push in from the outside of that shell into the pool. That can follow the path of least resistance, and you will get a weeper. They're not that common. I mean, we've seen a lot of them just because we have such a high concentration of problems that come to our desk. But by and large, it's a pretty rare issue to have a weeper. And sometimes they're active, like they're flowing like a water fountain. It's actually pretty crazy to see. But they're obvious. Okay, you will definitely tell there is an active weeper. And sometimes you try to patch it, like not you, but the plaster applicators will say, oh, no, we're going to put some hydraulic cement on it. We're going to patch that up, and then we're going to trowel over it. That doesn't always work because water's still pushing. There's still void spaces. There's still a weakness. It'll work its way around that hydraulic cement eventually, and you still have a weeper. So it's kind of like putting a Band-Aid on a dam that's leaking, or if you ever saw that movie Vegas Vacation where Chevy Chase, they're going through the Hoover Dam, and he sees a leak in the dam, so he puts his bubble gum there. It starts filling up the bubble gum, and then he's like, oh no, I got to plug the second hole now, and then another hole pops open. It's kind of like that. Water is still going to find a way through. So it's not waterproof. Concrete is not waterproof at all. it is porous. You can make it more watertight with proper density. So that's a weeper. Weeper can lead to taking minerals from that cement through to the surface, which is something called efflorescence, which is our next topic. Efflorescence is basically moisture migrating through concrete or cement or whatever you want to call it, and it takes calcium with it, primarily calcium, and it forms calcium carbonate on the outside. It looks exactly like scale because it is calcium carbonate, okay? But it's other minerals too sometimes. Efflorescence is just the transfer of minerals by way of water pushing through concrete. The most common places you will see this are on raised concrete walls where there is a moisture source behind it and it is pushing through. So think of a raised hot tub or spa. Very common to see efflorescence pushing through the grout of the stone around that spa or the brick or whatever. And it's not going to go through the stone because the stone is not concrete, but it will go through the grout. It'll find a way to push those minerals out if that spa was not waterproofed. All right, so that's a good example. That's a raised wall. Another one would be a vanishing edge, because the vanishing edge wall is a concrete wall that is holding back a swimming pool. Just like the hot tub is holding back the volume of that hot tub, that hydraulic pressure from the pool will push through that wall and it can bring through efflorescence. That is not the same thing as scale. Now, we know how to tell the difference usually, but there are some times where it's kind of hard to tell. The location is often around the spillway of a spa because maybe that area wasn't properly waterproofed entirely. And is it scale? Is it efflorescence? It's kind of hard to tell. But usually it's pretty obvious. If you have it on a place on the outside of a spa that is not around the pool, like on the backside of the spa, or it's not next to the overflow, pretty obvious that's going to be efflorescence, not scale. And another one would be if it's way above the water line. So let's say it's kind of over the pool, but it's 8 inches above where the water could possibly be. Well, how is that scale? How could water get there? It's not. It's efflorescence. It's pushing through the spa. When you see efflorescence, in general, that's a waterproofing failure. Or it's just a failure to waterproof. Moisture is traveling through. I also see it on retaining walls. I see it on like retaining walls of a garden where there's soil and plants and stuff. And, that soil holds water and eventually it pushes through and you get some efflorescence through that wall. Maybe that's not even connected to the pool, but it's in the backyard and people do send us photos of it. That's another common place to have it. So that's efflorescence. It is moisture taking minerals with it as it pushes through concrete. The final thing is calcium nodules. And I think this probably justifies its own episode or two in itself. But in the short term, I just want to kind of touch on it. Calcium nodules it's basically kind of like efflorescence on a smaller scale because it's only going through a half inch or so of your plaster or pebble or quartz or whatever you have, cement-based finish. It's kind of like efflorescence. In fact, it's very similar. It happens because there's moisture trapped in or behind the plaster cement. That's how nodules happen. Nobody disagrees on the fact that there is moisture in or behind it. There is a lot of disagreement in the industry over how the moisture got there. One side of the argument, and by the way, we don't really have an opinion here because we haven't done the experiments ourselves, but I will weigh in on the end of my experience on it. But both sides are pretty credible here. One side says calcium nodules are caused by aggressive water, low LSI water. It deteriorates the cement in the surface. It causes all this damage. It goes in, it extracts calcium hydroxide from deep within that cement. It pulls it out and you get these nodules. And I guess I should describe what a nodule looks like, because if you have a pool with a cement finish that has little white blisters in it, little mini volcanoes, they look like, blisters. Sometimes they ooze down and they're calcium, right? Little calcium bumps. Sometimes there's hundreds or thousands of them. Sometimes there's 1 to 2 or maybe 5 of them. Depends on what you have. But basically, they're small deposits of calcium that clearly come out of the wall or the floor, and they are raised. Like they're not flush with the surface. They are bumped. Okay, they bump out. And anyway, if you have it, you would know. But you can view our website, blog.orendatech.com, type in nodule or type in calcium. Eventually you'll find it. There's plenty of pictures on there. They come in a lot of different shapes and sizes. So that's one side of the argument. Aggressive water did this. It went in, it pulled it out, boom, nodules. Now the other side of that argument says, okay, well, aggressive water does destroy cement, no doubt, but it doesn't cause nodules because it doesn't destroy cement in that way. Their argument is this is either a workmanship failure or a waterproofing failure, in that there's moisture trapped behind the cement. How did it get there? Aggressive water is not going to pick a pinhole crack to go through. I mean, it will go after path of least resistance, but it would just kind of uniformly etch everywhere if that were the case. And so you wouldn't get nodules here and there. Notice that nodules almost always happen on the weakest part of the plaster, i.e. cracks. Almost every time I've seen nodules, they're either everywhere or they're in specific areas along craze cracking. That is no coincidence. That's a weakness. Just like a weeper is going to find the weakest point in the path of least resistance for water to push through the concrete shell, and just like efflorescence is going to push through the grout instead of the stone on a raised spa, for instance, it is always going to find the path of least resistance. Nodules are the exact same way. They are going to take calcium and they're going to, it gets pushed out based on pressure. So their argument is, no, this was originally caused by a weakness in the cement or bad workmanship or a failure to waterproof because something had to get the water back behind that cement in the first place. Then it comes out through weaknesses, deposits. Because if it was aggressive water, they argue, you would never see the nodule. You would simply dissolve the calcium hydroxide and it would stay in solution as you pulled it out. Well, that's also a valid point. So both sides of these arguments do have valid points in that, yes, low LSI water will destroy cement, but does it destroy it in specific pinhole locations, and does it seek to go through these cracks? I'm not entirely sure. But here's what I will say. And by the way, this is Eric's opinion, not necessarily Orenda's, but I haven't had a chance to ask everybody in our company for the opinion, and usually I'm the one dealing with this anyway in the company, so here we go. In my experience, calcium nodules are always either in the weakest spot of the plaster or they're everywhere. And 9 times out of 10, maybe more than that, it's a waterproofing failure. Once again, it could also be a failure to waterproof. This comes from water pushing from the backside, from what I can tell. Aggressive water on the LSI is something that we at Orenda intimately understand. We know what it does. We know what it looks like when it attacks cement. We see all sorts of variations on it. I am not convinced at this point that it's going to create little pinhole damage. Now, there's an exception to this, and it's a very important exception. In the first few days of a startup, if the pores are opened by doing an acid startup, a hot start, that can absolutely cause these channels to open up. And you can't put calcium hydroxide back in the cement after you've stolen it. So that is entirely possible. Aggressive water, i.e. an acid startup early on, could cause the initial damage that allows nodules to happen later, at least in theory. But in my experience, I have not seen it that it correlates with that. It is almost always there's a void space behind the plaster for some reason, or there's a weeper behind it. I've definitely seen that, where there's, here again, water coming through the backside of the concrete shell through a weakness, putting hydraulic pressure behind that cement, or the plaster, which is on top of the concrete, of course, and it fills up and it starts looking for the weakest spot. It finds a little crack or it pushes out, boom, nodules. Every time I've seen a weeper, and I mean every time, there has been nodules around it. Because, again, it's just another version of a weeper. A nodule is just a form of efflorescence, really. So if you've got a weeper behind your plaster, at least in my experience, if it doesn't just break open the plaster and run like a water fountain, it's going to create calcium nodules. At least that's what I've seen. And that makes perfect sense. There's a source of water behind it. The other times that I've seen calcium nodules is high water tables, groundwater pressure pushing through the back of the concrete shell, eventually putting pressure, hydraulic pressure on the backside of the plaster. Boom, you start getting nodules. This is especially prevalent in coastal areas. If you're near a beach or you're in the swamplands of Florida or wherever there's a high water table, nodules are going to be a much bigger problem. Whereas if you're up at elevation and the water table is much lower than your pool, you're probably not going to see them. Okay, because where's the water going to come from? You have to have some sort of pressure behind the concrete to do it, or they would have had to plaster on top of a big puddle or something, and that's highly unlikely. I guess it could happen, but I have not seen that happen. So anyways, as a recap, these are all kind of interrelated, and some people listening to this might think my opinion controversial, especially on the calcium nodules. But again, I've pored over the research, and I've looked at so many of these, and I'm trying to figure out what is the truth. All we know is water chemistry itself, if you balance the LSI, you can still have calcium nodules, which is one of the strongest arguments to say it's probably not water chemistry that's causing these things. Let me repeat that. You can still have calcium nodules in perfectly LSI balanced water because it's really a form of efflorescence. It's something happening behind. It's behind the cement and it's pushing into the pool. Now, if you maintain your water slightly aggressively, like in the yellow on the Orenda app, you might not see them. They could still be pushing calcium hydroxide to the surface. You just don't see it because the water's aggressive, it dissolves it, and no nodule ever forms. The other thought is, let's say it was a puddle or a void space or something, and it's just a finite amount of water behind there. Eventually, all the moisture is going to come out. Let it run its course, and you can sand off the nodule, and it won't come back, if that's the case. Except that's really rarely the case, because it's usually a consistent source of water because it's groundwater, 9 times out of 10. So anyway, these sources are basically about weaknesses in concrete. Okay, if the concrete shell is not dense enough and it was not waterproofed, I'm going to explain waterproofing in a moment, and I think that deserves its own episode as well. If it's not dense enough or waterproof enough, groundwater can push through it. Okay, and if it's a raised concrete wall, the pressure from the weight of the water in the spa or in the pool, if it's a Vanishing Edge or whatever it is, that will absolutely try to push through concrete. So the density of concrete is very important, and it will always find weaknesses, like if rebound was troweled in, that's a weakness. There's a void space. Boom, water might find that as the path of least resistance. So again, weepers are active leaks. You'll see water flowing. It's hemorrhaging. It's not dripping. I mean, it's moving water through concrete. Now, you don't see that underwater because the pool's full. You don't see water pouring into water, but chances are you're going to see some nodules forming in that area. So that's a weeper. Efflorescence is the transfer of minerals from inside the cement to the outside of the cement by way of water. Water is taking minerals, it's dissolving them along the way, and it's putting them out and depositing them on the other side. Most common places you'll see this are on raised spas, on the outside of raised spas, or any retaining wall, whether it's a Vanishing Edge wall or a retaining wall holding back a garden or whatever else out. Because that's, again, moisture pushing through, taking minerals with it. Nodules are a very fine form of efflorescence, basically, with water trapped behind that thin layer of plaster or pebble or whatever you have. It pushes through, boom, takes minerals with it. You got a nodule. That's the recap on that. So how do we prevent them? How do we clean them up? Well, short term is you don't. Like, you could hide nodules. You could make your water really aggressive and hope that it, dissolves away the nodules, but you're not solving the problem. You're not fixing them at all. And part of the reason I wanted to do this episode is these are not caused by water chemistry. So they're often not able to be fixed by water chemistry either. And that's really bad news for a homeowner, because if you do have these issues, it's a structural issue. And chances are it's going to be a renovation to fix them. I hate to be the bearer of bad news, but unless you want to keep dealing with it, you better fix the leak. You better fix the concrete. You better fix the source of the problem. So that's the first thing. How you can actually prevent it would be, well, obviously best practices from the start. Okay, but the main thing is waterproofing. If you know you have a raised spa or a Vanishing Edge wall, those walls should be waterproofed. Now, there's a multi-step process, and I think waterproofing deserves its own episode, but we're not a manufacturer of it. As it's explained to me, it's a multi-step process. There's a colloidal silica that is sprayed on, I think, within 3 days of shooting the shotcrete, and that helps densify it. And then a week or two later, again, don't quote me on this, I'm not the manufacturer, but maybe it's 2 weeks later, you roll on this waterproof membrane. And it takes 1 or 2 coats of that, and that helps. It doesn't just help, it is actually waterproof, and it'll seal that concrete so that it can hold water and be completely watertight. Unless you have weaknesses and you didn't put enough on, and you get the point. Proper waterproofing is highly recommended. Orenda recommends this, not just me. We strongly recommend it because we get so many calls about these problems. And yeah, it's not a majority of the calls we get, but it's significant. I mean, it's a lot of pools that have these problems. And I look at it and I think, wow, this could have been completely prevented with waterproofing. I don't know exactly what the costs of waterproofing are, but they are trivial compared to the cost of the pool. Yes, it's more time, it's more labor, it's more work. And right now we're in the midst of a labor shortage and everything is more expensive because of inflation and all that. But if you're going to build a pool, especially if you have a raised element like a raised spa or a Vanishing Edge, or if you're in a coastal area and you have a high water table, why would you not waterproof that pool? Some builders would argue, no, you just have to have proper shotcrete and it's going to be watertight enough, and then the weight of the water in the pool will push it out and it'll be fine. And maybe it will. I'm not saying you're wrong. You know a lot more than I do. All I'm saying is I see a lot of problems that could be totally prevented with a little more insurance. So why not? It's not a huge expense to waterproof these pools. So if you're a homeowner or a pool builder listening to this, we are strong advocates for waterproofing. You don't necessarily have to waterproof everything, but certainly if you're in a high water table area, you should. It just makes sense. And if you're a homeowner, demand it. You don't want these problems. Trust me. I've been in backyards where the homeowner spent $100,000 on this pool and there's nodules all over the place. And they find out there's weepers behind those nodules and it's forming cracks and they got to get it resurfaced. Oh, by the way, you can't just resurface it because you have to stop the leaks. Great. Well, how do you stop the leaks? Hydraulic cement? What, we're going to plug the hole in the dam with this finger and then another one opens up? You see the problem here? This could have been prevented had it been waterproof from the start. Now, if you do have nodules and it's just groundwater and it's not like active weepers or anything like that, unfortunately, the best fix I've seen is chipping everything out, chipping the whole plaster surface out, thoroughly waterproofing it, bond coating it, and replastering. You probably don't want to hear that, but that's really the only thing that I've seen that truly stops these problems. You can get down there and you can sand them off all you want, but there's no chemical answer to prevent nodules from coming back once they've started. It's a fundamental structural issue. So I hope that's a good recap. I mean, I'm kind of losing my mind. I'm trying to think of anything I might be missing. But yeah, again, we're not concrete experts, but we did write 2 articles about this where we cited several experts. And if you do have questions, feel free to reach out. We can put you in touch with those experts. And there's tons of information online anyway. This is just my opinion from what I've seen in the field. I hope it helps you. So if you do have weepers, efflorescence, or calcium nodules, feel free to reach out. And I think we will do a future episode on waterproofing and on nodules because it does deserve a little bit more explanation. But we'll probably take a break from this topic for a while. This has been episode 41 of the Rule Your Pool podcast. I'm your host, Eric Knight. Thank you so much for listening. And if you think that this would be a worthwhile episode to share with your friends who may have a pool, hopefully they don't have these problems, but we'd love for you to share our podcast. So thanks again for listening. Until next time, take care.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.